Hello. Okay. So, good morning, class. Okay, no problem. We'll cover the module. Don't go this module number. Okay, today actually we'll cover the logic gates. Okay. So, already in your lab you have performed logic gates. Okay. Just 1 second. Okay. No, no one is waiting. Uh, acha, let me just unlock the meeting so if anyone can join within 5 minutes. Okay. So today actually I just give you a brief of logic gates. Okay. So actually to say what are the logic gates we already know that. First of all, in this digital electronics or digital system, okay, we the building block of the digital systems are logic gate. Okay, so if I say the what are the building blocks of analog system, then you can say that in the analog system there are diode, there are resistor, there are capacitor, there are inductor, there are transistor. Like this, these components are mostly used to prepare any circuit in analog system. Okay, so that because of that those components are known as your building block or building like building block elements. Okay, like that in digital system also, if you try to if you try to design a system, a complete digital system, then the building blocks or primary blocks that you required are these logic gates, this and gate, or gate, not gate, NAND gate, NOR gate, XOR, XNOR. Okay, there are also buffer also. Buffer is a kind of a gate. We will see that you can also record some buffer also in some cases. Okay, so these are actually known as your basic building blocks of logic gates. And you see, if you there is also a one chapter that is logic family. Okay, so just 1 second. Logic family. Okay, so what is actually logic family? So logic gates and logic family are actually interconnected. Okay, so you see you can see this document that here you can see the name of the logic family and components used. Okay, is it visible? Yes.
Yes, sir.
Has sir, visible.
Okay, so now you try to you can connect. I'm talking about logic gates. So actually, what are the logic gates? Logic gates are and, not, NAND, like this. And how these logic gates are formed? They are formed with the help of these logic family components, these logic family members and their components. Okay, so you can see what name of the logic family members, like DL is diode logic, RTL is the register transistor logic, then your DTL diode transistor logic, then your TTL transistor logic, then your ECL emitter coupled logic, then PMOS, then NMOS, then CMOS. So there are lots, 1, 2, 3, 4, 5, 6, 7, 8. 8 family members are there in logic family. Okay, so using these logic family members, anyone, say you can design all the types of digital building blocks like digital gates, logic gates, using any of this family member. You can take DTL. So using DTL, you can make NOT gate, AND gate, OR gate, NAND gate, every gates. Okay. Using TTL, you can make it. Using ECL, in PMOS, you can make these things. Okay. Now, why these? There are so many options are available. So the answer is, initially there was not so many options. So initial means at very beginning there is only diode logic, then there is improvement, so RTL came, then DTL came, so register transistor came, then diode transistor came, then transistor came, then ECL. So this is actually the improvement down. As you go down, you will get the improved version of logic family. So CMOS is the ultimate, means improved version of the logic family. Okay, so there are lots of advantage if you choose CMOS logic family to design your logic gates. Okay, now you see, basically this digital electronics, analog electronics actually mixed with each other. They are all interconnected, because you see, if I say that you are using CMOS or suppose RTL, so basically in the back of that design, you are actually using register and transistor. Okay, so these components are not digital, these components are analog. Okay, so this is the concept, means, uh, though we are talking about digital systems, digital logic blocks, digital gates, but actually we are connected with analog components. Okay, so you can see for each and every logic family there are analog components are connected. Okay, these components are used. Diodes are used. This is analog component. For register and transistors are used. This is also analog component. Diode transistor, so diode, transistor, resistors are used. Analog components. So all these are analog components. So basically, without this component, anyone cannot design any digital block. So with this, using this component, you can design any of these family member, and using this family member, you can design any of the block. Okay, so so first thing, so this is the concept of designing of the logic gate. Okay, so you can see that now, suppose you try to design a system using digital mode, means you try to design a digital system. So in the digital system, what you have to look out, or what is your primary criteria? The primary criteria of the digital system, that it works on digital value, discrete magnitude value. Okay, not analog like continuous value. So it will take either 1 or 0. Okay, so either plus 5 volt or 0 volt, right? So sometime in some system there will be a plus 5 volt, means 1, so there will be another voltage plus 3.3 volt, that is also considered as 1. Okay, so high or low, this kind of thing are happening here. Basically all these points, true false like digital, 1 0 also digital, plus 5 volt, 0 volt, this is also digital, high or low, this is also digital. So basically these notations we oftenly use when we are talking about digital system. Okay, so now you understand that what are the digital system and how they are connected with the analog system, and what is logic family. Okay, so we will discuss logic family elaborately in future, but today we will try to see the logic gates. So basically, actually, the logic gates are very, means your building blocks of digital system, and we all familiar with this. Okay, So basically this is a NOT gate, we all know that. So the thing is that when you are giving a low input, you are getting a high input. Okay, so this is the thing. And suppose where you can use this NOT gate. So use of NOT gate like this, you can think this circuit component. Okay, so can anyone describe me how this circuit is working? What happened if the switch is connected to one position? Hello.
Yes, the bulb will not glow.
Yes, bulb will not glow. Why?
Yes, because the current will always try to pass through the path of least resistance. মানে
Exactly.
যেই পাথে সবচেয়ে কম রেজিস্ট্যান্স থাকবে ওই পাথ দিয়ে ফ্লো করার চেষ্টা করবে সবসময়। তো
একদম।
বাল্বের দিয়ে ফ্লো করবে না।
Exactly. So that means this NOT gate actually used as a switch. Okay. So what is switch? Switch is something like that. When you are connecting, switch means you can connect on and off. So if it is connected to one, then all the current of the circuit will go to the ground. Okay. So lamp will not glow. If you not connecting this, so it is open state, then the current will pass through the lamp and lamp will glow. So you see this is actually acting as a switch. So this is the concept of NOT gate. So whenever there is a requirement of a switch, then you can use NOT gate. Okay. Now coming to the AND gate. So we all know that AND gate is what? AND gate is the ANDing the two input operation. So when you are giving 0 0, getting 0, when 0 1, also you are getting 0, 1 0, that is also 0, double 1 means when both are high, then only you can get the result. Okay, so that means if I connect, think about a circuit like this, where there are two switches connected in series. Okay, then I can make a NAND gate, sorry, AND gate. I can make a AND gate. Okay, you can see that AND gate means ANDing two operation. So both switches should be connected with one, then only the lamp will get the current to glow. Okay, so the system where you have to take decision depending upon two variables. So and both variables should be one to make things happening. So in that kind of decision, you can use AND gate. Okay. So AND gate also a decision making gate. How to you make a decision? If your system will give a output only when both inputs are one, then only your give system will give you out. So in that case, you can use AND gate concept. Okay. So this is AND gate. Similar to that, OR gate. So what is actually OR gate? So in the OR gate, for both input, or when both inputs are 0, then only you are getting 0. And if any one of the input is 1, then you are getting 1. Means when you are getting output, when any of the input is 1. Okay. So if I draw this circuit, so how can I draw? So this is the drawing of the circuit. We see one input is connected to 1, so B is fixed to 1, and one input is varying, so that I can get a different state of the circuit. So if the connect A switch is connected to 0, then you will get what you will get, you are getting output. Okay, and suppose A switch is connected 1 and B switch is connected 0, then also you are getting output. Okay, so all when there are two parallel path, so current can pass through two parallel path. Okay, depending upon the switch position. Okay, so OR is something like go this way or go to this way. There are two paths available, go this way, go this way. But if and only if both are switch are off or connected to 0, then there will be no lamp light. But the AND gate is something like go to, means you have to go through two switches sequentially. Okay, so there is no parallel path, this is a series connection. So AND is nothing but a series connected switches, and OR is your parallel switches. So you can take any of the two paths, okay, depending upon the switch value. Okay, and there is only one case when both paths are open. The case is when A is 0 and B is 0. Okay, so this is actually OR gate. So OR gate produces result whenever there is one input is 1. Okay, and AND gate produces result only when there is both are 1, when both variables are 1. This is the difference. Okay, so let's go to the next one. So NAND gate. So what is NAND gate? So NAND gate is kind of an inverter. So you see that whenever there is a bubble sign, so this is if and inverter, right? So this is actually what inverter, add then inverter. Okay, so and inverter means, so inverter we have already seen this circuit diagram of inverter. So this is circuit diagram of inverter. You have to a bypass path for to the ground. So that is the inverter. Okay, so a bypass path to the ground parallel to the load. That is the inverter. Okay, so same thing here also you can see that there is a bypass path to the ground parallel to the inverter, parallel to the load, but in that path there will be two switches because this is two input gate. Okay, so if the both switches are connected, then only you get nothing at the lamp. Okay, there is a noise coming from, hello, hello. Okay, so the thing is that this is a AND inverter. So if I think design a circuit, so I will design this kind of circuit where the inverter concept is there. The parallel to the load there is a path to the ground, and there will be two switches because there are two input. This is a two input and NAND gate. Okay, so and both switches are one, then only you will get zero. There will be no light. If anyone is, and you can understand from this figure that if anyone is connected to one and another is zero, then the path is open, so no current will flow to the ground. Okay, so this is the and NAND gate. So NAND gate produces logic 1 if either one or both of the inputs are at logic 0, else output will be at logic 1. Okay, so actually what is they saying, the NAND gate produces a 1 when either of these two input is 0, like 0 0 0 1 and 1 0. So either of these two inputs are 0, then only it will produce output 1. And for if both are 1, then it will produce output 0. Okay, so that thing is noted here. So NOR gate. So NOR gate is what? Inverter. So you can see there is a parallel path to the ground, parallel path to the ground, parallel to your load. Okay, but in the NOR gate, so you will see that NOR gate means something parallel. Means it is giving a parallel path to parallel switches. So there will be two parallel switches as well as both switches should be parallel with your load. Okay, so that will give you a NOR gate. So this is the load lamp. So this is a parallel path to the load, and there will be two switches, and those two switches are connected in parallel. So this is actually a NOR gate. So depending upon any value, if any switch is connected to one, then you will get no lamp light. So you will basically this will produce lamp light only the one condition, both switches are at 0 position. Okay, then only you will get 1, else for any condition you will get 0. That means if any of the input is 1, right, then what you are getting, you are getting 0. Okay, so just opposite to NAND, if any of the input is 1, you are getting 0. Okay, so this is XOR. So what is XOR? So now it is not something like you can connect with other gates. So XOR is different. Oh, it is not written here properly. XOR is a. So what is the XOR? XOR is A bar B. So this is a truth table. If you see the truth table, then you can understand. If the both inputs are 0 0, you are getting 0. If both inputs are, means both inputs are same, you are getting 0. if any of the inputs, when both inputs are different, okay, then only you are getting 1. Okay, so this is actually 2 input XOR gate. If you consider a 3 input XOR gate also, the truth table is same. If the 3 inputs are same, then only you get 0. If any of the input differ from other 2 inputs, then you will get 1. Okay, so if I make a circuit depending upon this this truth table, so I can make this kind of circuit. This is a little complicated. You see, the lamp light, the load is connected to switch 1, B is connected to switch 1 or switch 0. Okay, and A can be connected to switch 0 or switch 1, but only the switch, the line of this is the line which is connected to the load. So suppose B is connected to this position, A is connected to this position. So you are at same time you are getting a complete circuit diagram. Means there will be complete circuit diagram when A is connected to 1, B is connected to 0, or A is connected to 0, B is connected to 1. But if both are connected to 1, then you see there will be, the circuit is open. If both are connected to 0, so their circuit is open. So 0 to 0, there is no connection. This 0 to this 0 point. So both switches, if connected to this 0 position, then your circuit will be open. So lamp will not glow. So lamp will glow only when, if any one of this is connected to 0 and other one is connected to 1. Okay, so this is actually the XOR gate. Okay, so next is your XNOR. So XNOR is just opposite of, means just inverted of XOR. So this is the expression of XNOR, A B bar plus A bar B, and there is a whole inversion. Okay, so that means just invert it. So the truth table, if you see the truth table, this is the inverted truth table of previous one. Okay, so in this truth table you see there is a you will get always high output, or you will always get the output when both inputs are same. So whenever I am talking about, or any conditions arise where if the both inputs are same, then only your system will give output, then you have to design a XNOR gate. Okay, so this is a practical scenario. So in practical scenario, suppose you are designing a system where there are 2 inputs or maybe n number of inputs are coming, and only when output you want when all the inputs are same, then only you will get the output. So in that case you have to design a XNOR gate having n inputs. Okay, so you see here also you can see that if I design this circuit, so the switch positions are should be like this, parallel. So if both are 0 0, then there will be a complete circuit. If both are 1 1, then there will be a complete circuit. But if A is connected 1 and B is connected 0, so there will be this circuit will be open, so there is no current. Okay, so this is what XNOR gate is doing. Okay, okay, so these things I think clear to everyone. Okay, right? Okay, so next is your IEEE standard symbol. So we need to know this also. Okay, so IEEE standard symbol is what? So in my previous lecture, I was talking about your what I am talking. I was talking about the symbol, the notation ASCII. We are talking about ASCII of 7 bits. Okay, so in that case, we have seen that we can represent not only the numeric values. Okay, we can also represent uppercase of alphabets, lowercase of alphabet, different symbols using IEEE ASCII notation. Okay, so similar to that, this IEEE ANSI, so American National Standard Institute ANSI has provided this notations, okay, for the gate. So this is the general notation of the gates, but IEEE is the standard, international standard. So international notation of the gates, you should, means it will be better if you know these things also. So it is good to know that this is the international standard for denoting a gate. Okay, so you see that this is fixed, we cannot change. So if I talk about inverter, then there will be a like this is a signal of inverter. This is the inverter block. Okay, there is a rectangular block. One means inverter, and means and means this and gate. Sorry, greater than equals to one means or gate. So NAND gate means and, so and then there is the inverter sign. Okay, and NOR gate means or, there is the inverter sign. This is the inverter sign. And this, when it is double equals to one, then it is XOR, and it is double equals to then inverted, then it is XNOR. Okay, so this is good to know. You should know this thing, that these are the representation of gates by normal way in books, but this international standard of representation of gates. Okay, so going to the next part. So next is we'll see the universal gates. Okay, so universal gates, we know already the gates which are used to design other gates. So using NAND gate, you can design any of the gates. Okay, so that's why NAND is your universal gate. Okay, and NOR gate, using NOR gate you can design any of the gates. And why the concept of universal gates is coming? Uh, because you just think, suppose you are designing a complex digital system. Okay, suppose you are designing a complex digital system, and in that digital system, if you have n number of different elements, so then what you have to do, you have to manufacture that n number of different elements, right? So now you think, if you designing the same system, okay, but here you have n number of elements, but all elements are same, then that will be a very good condition to design that system. So that is the thing, that is the reason why universal gates are come in this scenario. Because universal gates, suppose if you have a NAND gate or if you have manufactured a single NAND gate. Okay, so if you manufacture a single NAND gate, using that multiple NAND gate, you can design a system, because you can design any kind of gates using that NAND gate. So it will reduce drastically the cost of designing of the system. You can say the complexity of designing of the system. So there will be huge advantages to by using these universal gates. Okay, so that's why the universal gates are means present in this scenario. Otherwise there is no need. If means if you designing if you can design a system using different gates, okay, different components, different variety of components, then your complexity of design will increase. If you can handle that thing, then there is no need of universal gates. But this is not a practical scenario. In the practical scenario, it is good to use a same kind of gate to designing a complete system, at least, means at most of the time, most of the time, not for all time, but most of the time. Okay, so we'll see that how we can convert our NAND gate using how we can design a and NOT gate. First NOT gate using a NAND gate. Okay, so how we can design, so we will see this also today's lab also. Okay, so using NAND gate, we can design a NOT gate, right? So what I have to do, I have to just short circuit the both input. Okay, you see what is the equation of NAND gate? A into B, then bar. Okay, A into B whole bar. So if I short circuit and giving a, so A is going as an input, and you are getting not A. Not A means nothing but your what? Inverter output. So you are getting an inverter output by this design. If you want to design a AND gate, then what you have to do? So you have to give these two gates in two inputs, because AND gate always have two inputs. Okay, then you have to design an inverter and then inverter. So this is actually a NAND gate. So NAND gate, after then there, if there is an inverter, then you will get an AND gate, right? So so this is actually not of A and B. You see the notation, what it is? It is actually not of A and B, and if you do again another not, the not of not, then you are getting A and B. So this is actually A and B. Okay, and uh, this is the case for your what? So you are getting and, okay, OR gate. So this is the case for your OR gate. Okay. So of OR gate, how can you design an OR gate? Okay, OR gate, to design OR gate, you have to give two inputs. So two inverted inputs, A bar and B bar. If you connect A bar to B bar to the input of the NAND, so then you will get a output A plus B. Okay, so this is what you can give. Okay, so just, so is it clear to everyone? This is how I am getting the OR output from this. A inverted and B inverted, right? Okay, A inverted and B inverted. So you have 5 minutes, so I cannot go further. Okay, so just you need to give your attendance here. So today up to this means we have seen the different gates. Okay, and the conversion I will see in the next class. Okay, the and NAND and non conversion will see in the next class. Okay, and there will be also some other gates also. So the next class we will see that. So have you downloaded any book, digital electronics book? All of you, this question for all of you. Have you downloaded any digital electronics book?
In books PDF.
PDF. Okay. So what is the writer name?
So you send any books PDF. We don't know any good books name or any good books writer name.
Okay. So I can share
আপনি
one
একটা
book.
রেফারেন্স দিয়ে দেন না বুকে, তাহলেই তো হলো, আমরা ডাউনলোড কিংবা করে নেবো ওটা থেকে একটা।
আমি দিয়ে দিয়েছি, মেল করেছি অনেকদিন আগে। তোমরা মেল চেক করো, কমন মেলটা চেক করো, আমি দিয়ে দিয়েছি, অনেকদিন আগে দিয়েছি।
অফিসিয়াল
সেজন্যই জিজ্ঞেস
গ্রুপে
করছি,
দেওয়া হয়েছিল।
অনেকদিন হয়ে যাওয়া।
এই সবি
হ্যাঁ, দেওয়া
অফিসিয়াল
হ্যাঁ
হয়েছিল।
গ্রুপে
হ্যাঁ
দেওয়া
আচ্ছা,
একটা পুরো করে লিস্ট দেওয়া হয়েছিল।
হ্যাঁ, তোমরা দেখো, ওখান থেকে ডাউনলোড করার চেষ্টা করো, ঠিক আছে? কারণ একটা বই থাকলে তোমাদের একটু সুবিধাই হবে। Because I cannot give you all notes, because my notes will be very not every information I can give in my notes. So a book will be always good. So that is the thing. Okay, so thank you.